Hey guys, welcome to my channel, and today I'm recording Cambridge O Level 5070 Paper 2 Chemistry Theory paper. This is May June 2021. It is around 1 hour 30 minutes paper. Today I'm recording part 4 of this video. I have already recorded part 1, 2, 3 of this paper, and this is the fourth part of the video. If you want to check out these questions, you can go and check out in the link of the playlist down below in the description box. So without any further ado, let's start from question number 7. Question number 7 says sulfamic acid NH2SO3H is white crystalline solid. It reacts with aqueous sodium nitrate to make nitrogen gas as shown in the equation. NH2SO3H NaNO2N2, this is the whole equation given to us, alright. Part A says an excess of sulfamic acid reacts with 20 centimeter cube sample of 0.15 mole per dm cube NaNO2. Calculate the maximum volume in dm cube of nitrogen formed measured at room temperature and pressure. Alright, so I've already written the whole solution of it because it takes a lot of time in calculating during the video. It's a hassle, that is why. However, I'm going to completely explain it to you. So first of all, let's hide this part. Alright, an excess of sulfamic acid reacts with, if we start highlighting over here, so basically it is reacting with 20 centimeter cube, which is the volume, and this is the concentration of NaNO2. Alright, here we are talking about NaNO2. Calculate the maximum volume in dm cube of nitrogen formed measured at room temperature and pressure. Now for nitrogen, let's consider the blue highlighter. Alright, nitrogen. Now first of all, you need to see that what data is given to us. We basically have sulfamic acid, we have the volume, and we have the concentration. We can easily use N is equals to C into V, that means moles is equals to concentration into volume, and find the number of moles, and then through ratio method, which is 1:1, we can find automatically the moles of N2. Now here we are talking about maximum volume in dm cube, which means at room temperature is also mentioned. Room temperature is basically 24 dm cube. This is a standard value, probably given in your data booklet too. You can look from there. So I hope you've understood the whole question. Now what have I done over here is I found the moles using the formula, N is equals to C into V. Why did I divide by 1000? Because this is in cm cube and we are supposed to find in dm cube. That is why 20 divided by 1000, which gives me an answer of 0.003. Now this is about, if you see, this is sulfamic acid. Alright, this is the moles for sulfamic acid. However, 0.03, since it is into the ratio of 1:1, the sulfamic acid, the number of moles will be same for nitrogen too. Remember, this only and mainly applies to moles. Alright, then moving on, if we multiply by 24, as I just said, at room temperature it's 24 dm cube, we will get the volume of nitrogen. Alright, so for getting the volume of something, you need to multiply moles with 24 and you will get the volume of it. Moving on to part B, the rate of this reaction can be determined by measuring the volume of nitrogen formed every second. Draw a label diagram of the assembled apparatus that can be used to make, collect, and measure the volume of nitrogen formed in this reaction. Okay, so basically, if you see over here, this is if you see over here, we have solid and aqueous things together, that is the reactant, and in product side we have gas, we have liquid, and we have an aqueous solution with us. So always remember, whenever we're having gas as a product, we are going to use a syringe for it so that we can collect the gas. Alright, so since I do not have the ideal tools to draw it, so I'm just going to brief it out for you guys a little bit. So because we have aqueous and solid, so we are going to put it in a conical flask which will be covered with a cork. Alright, cork wise, so that all the product remains into the system, alright, into that conical flask. And the product, because we have nitrogen gas too in it, So nitrogen gas, we are connecting a gas syringe in such a way through the cork that nothing can leak out. Alright, and then we'll connect gas syringe with it, and after connecting gas syringe, it will collect the gas, that is nitrogen gas, and yeah, that's it for it. Also make sure you label all of it. That is the solids and the, like, gas and all, wherever we are getting all of it. Alright, so moving on to part C. The concentration of NaNO2 aqueous is increased, the temperature of this reaction remains constant. State and explain how the rate of reaction changes. Now here we are talking about the concentration of NaNO2. Alright, remember that whenever we increase the concentration of one side, the other side of the reaction automatically increases. So if we are increasing concentration of reactant, that means greater product will be formed and the reaction will be faster because we have more surface area increases. Alright, and more collision can take place, more successful collisions. So basically that is why the concentration is directly proportional to the rate of reaction. So if we are increasing, as you know, NaNO2 is a reactant. If we increase the reactant, the forward reaction will increase. That means the rate of reaction will increase. And because, do we have to explain why, right? So we have to explain how. So it is because there will be more particles, hence there will be more successful collisions. That is why the rate of reaction will increase. Moving on to part D, sulfamic acid forms salt called sulfamates that contain an anion NH2SO3-. Magnesium carbonate MgCO3 is added to a sample of NH2SO3H. Magnesium sulfamate, water and a gas are formed. The gas turns lime water milky. Construct the equation for this reaction. Okay, so this is basically a 3-mark reaction. So you need to be very careful and vigilant. So here we have sulfamic acid forms salt called sulfamate that contain an ion of NH2SO3-. Now this is the product side. Let's keep it aside. Then we have magnesium carbonate is added to the sample of NH2SO3H. That means magnesium carbonate, that is MgCO3, is added to a sample of NH2SO3H. Alright, then magnesium sulfamate, water and a gas are formed. Now if we talk about the product side, so we have magnesium sulfamate, water and a gas. Now we need to identify the gas too, that we'll get to know through the reaction. So also we also have a hint given over here with us, a sort of a hint that whatever sulfamate is, it has this as its anion. Alright, so let's construct this equation. Alright, so this is how the equation will be formed. Now we're supposed to balance it. So for balancing, you need to use basic trial and error method. So over here we might have to, and yeah, it's probably balanced. Alright, not a big deal. Now, how did I get to know the gas? Because of this. Lime water turns milky with carbon dioxide only. That is why carbon dioxide will be formed. Water and magnesium sulfamate that we have over here. Alright, it was very simple because I'll tell you why. Because we have MgCO3 given with us, we have NH2SO3H given with us. Both the reactants are given, and then we have magnesium sulfamate. Now over here we don't only have magnesium, we know magnesium is Mg, but we also know that the anion of sulfur mate is NH2SO3 minus. That is why we have showed the reaction, and then water and carbon dioxide. Even if you have no idea of how to make a reaction or how to determine the products from the reactants, it is pretty simple because both reactants and the products are given to you. They're literally given it to you in the question. The answer is already given. All you need to do is a bit of balancing, which is also pretty easy, and identifying the gas. That is what gas turns lime water milky, which is carbon dioxide. Alright, so that's it for this question. Moving on to question number 8. Lead is a metal with proton number 82. Use a periodic table to state the number of occupied electron shells in an atom of lead. Let's move to the periodic table, and we need to find the occupied electron shells. Occupied electron shells can be determined from which number of group it is in, the group number basically. So if we see over here, we have lead with us, that is lead is 82, and it's 20.7, which is in group 3-4. Alright, so this is basically in group 4 and period number 6. Alright, so I would like to read the question because I think there's a bit of confusion. Okay, I forgot the question. So basically the question said use a periodic table to state the number of occupied electron shells in an atom. We're talking about the occupied electron shells, not the outer valence shell. That's my bad. I'm sorry for that. We are basically going to tell how many number of shells are with lead, are in a lead atom. So basically, if we look at the period number, we'll get to know. So the period number is 1, 1, 2, 3, 4, 5, 6. Why do we have a lot of highlights over here? So basically, lead is in period number 6, so the answer for this is 6. So moving on to part 2, use a periodic table to state the number of electrons in the outer shell of an atom. We just saw it is 4. It is in the fourth group of the periodic table. Moving on to part B, describe with the aid of a label diagram the metallic bonding in lead. Now if we are talking about metallic bonding, we need to also draw a diagram, which is must in this question. So usually at times it's a choice, at times you are supposed to draw, depending on the type of question. So basically metallic bonding is when we have positive ions closely together and we have delocalized electrons, a sea of delocalized electrons around it. That is how metallic bonding is formed. So metallic bonding is the electrostatic force between the positive ions and the delocalized electrons. Alright, so I hope you understand. You can draw positive ions and you can draw sea of electron around it. Pretty simple question. Moving on to part C. In case you want to know how to draw it, you can check out my previous videos of different years. I have drawn this several times. Moving on to part 3, give 2 physical properties of lead that are characteristics of all metal. So we need to tell about lead, and it is also characteristics of all metals. So basically you can write general metal characteristics such as they're good electrical conductor, they're shiny, they're malleable, any two of them. Moving on to part D, lead 2 ethanoate is white crystalline soluble salt. Name a suitable combination of an acid and an insoluble base which is used to prepare lead 2 ethanoate. So for lead 2 ethanoate, we need to see is used to prepare. We can, if we are talking about acid, we can talk about ethanoic acid. If we react ethanoic acid, we can form it lead 2 ethanoate, and then for base it will be lead hydroxide. Alright, so that is it for it. Moving on to part E, aqueous lead 2 ethanoate reacts with aqueous sodium iodide. A yellow precipitate of lead 2 iodide PbI2 is formed. Construct an ionic equation with state symbols for this reaction. If we draw the ionic equation, it's going to be something like this. Alright, so this is how you're going to do it, and now I'll balance it. So it's like this. Because we need to draw an ionic equation, this is how you can make it simply. Moving on to part F, explain why solid lead to iodide cannot be electrolyzed. Solid lead to iodide cannot be electrolyzed because they do not have any kind of delocalized electron. There are no delocalized electrons, hence electrolysis cannot take place. So this is how you're going to solve this question and easily get 10 marks. That is it for this video. I'm going to solve the rest of the questions in my next video, which will be up really soon. So also make sure to like, subscribe and comment any kind of improvements that you want, any kind of queries that you have, and I'll make sure to address it in my future videos. Thank you so much for watching and best of luck for your exams.